Hey, let's do some post-test analysis together. So I got some data from my tests, and I'm gonna manually determine if it's a win, yes or no. And this is called post-test analysis. What I'm using today is the A/B test calculator from CRO. There are, of course, multiple calculators, and in this version of this recording, I'm gonna use Bayesian Statistics. First of all, my test run 7 days. And I'm going to check here the number of transactions. And what I think is nice about seeing this being done live is that you can learn a lot, right? If this is your first time seeing this, then it might be interesting for you. Cool. So if there would be a problem in the data distribution of the two groups, you would see this alert, which is called sample ratio mismatch. If you see this alert, means there is generally something really big wrong with your test, like a bug or it didn't run on all devices. What you see here is it immediately calculates for me the conversion rate, the lift, and the number of extra transactions. So that's interesting. But how do we know if this is actually a change that we will implement, yes or no? So let's take a look here. These are set up just by default, but I immediately go to the results here, and you see this is set to Bayesian. I think most people in companies use Bayesian statistics. Not necessarily though, but it really makes for a good discussion about, are we going to implement this change, yes or no? In this case, you have 95% chance that the variant is better. So this chance, if you're in a discussion with a stakeholder or with the team, 95% is pretty good. So you're probably confident to implement it. And with different statistics, frequency statistics. I also have a client that really wants to do frequency statistics, which uses the z-test, as you can see here. And the result is just a little bit more straightforward. You talk about, okay, it's better, yes or no. Significantly better, yes or no. Or worse, of course. In this case, okay, it's a clear win and it's easy to talk about wins, but it could be that your control has 95% chance to outperform and you will have a losing test. Of course, that's also an option. Or it will be like 60% chance to be better than control. And then it's really up to you. Will you implement this change because it's just the direction you want to go? Like the strategy you want to take with the brand or whatever that is, or it costs too much money. And that's also good to talk about the money here. So for example, let's say this is a web shop and these are really regular conversions. And I know that for this web shop, the average order value is $80. Let's say $80. And then what you see here is that based on that $80, and that 7 days that we put here, we see the number of extra transactions, and then we see the monthly monetary contribution based on that. So that's cool. And it's an estimate, right? If you want to get a little bit more precise in this estimate, then you can use another tool, which is this one, but I have to transfer some of the data. It's called the A/B test guide. And as you can see, I'm just copy pasting data, but know that more mature experimentation programs automate all this stuff, of course, so that you don't have to do this manually at all. So here you see kind of the same results. It's a little bit more precise. And you see here kind of the chance of winning. What is pretty cool here is that you can add same average order value, and here the cost of implementation in a way. So I know that for this client, they will have to translate to French and German. Let's say that translation and maybe also development costs, because they don't always have a developer, it will cost like 5,000. Well, we're working with euro here. It doesn't really matter. And then you want to kind of get back that money. And what you see here is that it takes that money into account, and you see kind of the probability of having this risk, which is 4% risk on having this minus effect on revenue. And then you have the probability 95% of having this effect of revenue. So this is interesting. Of course, you can also, I think you cannot put a zero in here, then it kind of freaks out. Yeah. You can also put one to make the price of implementation very very small, and then you still have this cool graph, which can help in your conversation with stakeholders maybe. Cool. So we have that, and generally, what people do then is we do some documentation, and some people do this fully in Airtable, fully automated. But I think for the most of us, we have like a test document that we save somewhere. Test document is usually like, hey, why are we running this test? And then you write down here like, hey, we did this research, we found this. Let me put this on slideshow, it's nicer. We done user testing, we found this thing, and that's why and then you fill in the hypothesis. And this is something you can do already before, of course, before running the test. Then you need somewhere to have all the details of the test so you can rerun it, screenshots, link to design, split, date range, and of course, what you're going to measure if it's a win, like what you're going to base that on, an overall evaluation metric in a way with secondary guardrail metrics. And then a scorecard where you say like, hey, it's a win, yes or no, why, and you can summarize the data. And I think most important is to have recommendation and next steps. So most people, if they start out with A/B test reports and post-test analysis, they just summarize the data like, hey, it was significant, or hey, it had so much percent of being better. But in fact, you also want to say like, okay, implement it, or let's start iterating it, or let's choose a different strategy first to test before we implement it, because implementing costs money. Or let's abandon this hypothesis. And sometimes also this is a space to talk about, okay, based on this data, maybe you have some heat maps, maybe you watch some session recordings of your variant, and then you can also say, based on all this, we also got these 3 new ideas that we like to test, especially if it's a win, you want to keep testing in that direction. But also if you have a losing test, what you want to do is you want to kind of test in the opposite direction. So if your hypothesis was to add social proof and it lost, then try to remove all the social proof from the website, and maybe that will be better for you. So that's kind of how you can deal with losses. If it's not significant, you can think about, should we have tested this change in a bigger way? Like, could we have changed something above the fold, or could we have changed it on multiple places based on the hypothesis? That's one thing. Sometimes the data sample is just not big enough to find a change. That's also possible. I think non-significant results are most common, probably. Most of the things we come up with don't actually have such a big effect at all, although we think so. And then what I wanted to show, sometimes there is a raw data slide in here, and I haven't filled it out completely, but you can, of course. And then, everyone that wants to look at the data can. You can add heat maps, and this is something I wanted to talk about. So in Bayesian, you see like we had that result of 95% chance of outperforming the control. And it's when something is a winner, it all is based on what you determine a winner will be with your client, or with the rest of your team, or with the full organization. In many organizations, a winner is already when something has 80% chance of being better than control. Sometimes it's 85, sometimes it's 90. But of course, based on that, you will also determine when things are kind of not significant, or when things are a loser. So keep this in mind when working with Bayesian statistics, and change this up. If this is 80, then this becomes 20, of course, and these numbers also change. You can have a table like this to work with. All right, I think this is it for now. I hope this helps. If you have any questions, just reach out to me on LinkedIn. All right, have fun. Bye.